As was mentioned in a previous screencast, most linear equations aren't solved in just one step. So let's take a look at a new example. Solve the equation 17 equals 2x minus 1 for x. This is a multi-step equation. So let's first identify what's happening to x in this particular equation. So notice that x is being multiplied by 2, and we're also then subtracting 1 from that. So to undo multiplication by 2, we would need to do division by 2. To undo subtracting 1, we would need to add 1. Of course, we would need to do that to both sides to maintain the balance. However, which one of those two would you want to do first? Let's try it both ways. So down here, should we add 1 to both sides or divide both sides by 2 first? So if we took this equation and added 1 to both sides of the equation, so 17, I'm adding 1 to that, and I'm adding 1 to the 2x minus 1, and notice this gives me 18 equals 2x. This equation is equivalent to the initial equation. That's with adding 1 to both sides. Let's try instead from the initial equation dividing both sides by 2 to start. 17 over 2 is technically the fraction 17 halves. It doesn't reduce, and we're not converting to decimals in general in this course. And over here, we need to use the distributive property because of this subtraction in the top. 2 divides into 2x, giving us x. 2 goes into 1, just giving us 1/2. This new equation is equivalent to the original equation. Which one of these equations would you now want to work with to isolate x for? You could technically do it in either of them, but almost everybody on the planet is going to say they'd rather work with this equation than this one. So it is prudent for us to add 1 to both sides first instead of dividing both sides by 2. While both are legal, one is easier than the other. So our strategy is going to be this. We want to isolate the variable by performing the inverse operations in the opposite order of the order of operations. So we work backwards from the order of operations when we want to solve equations, meaning we should do addition and subtraction before we do multiplication and division, and we should do that before we do exponentiation. So when solving equations, we go in the opposite order. So instead of going from exponentiation to addition and subtraction, we go from addition and subtraction to exponentiation in that order. We will not be dealing with exponentiation since we're only solving linear equations which have the variable raised just to the first power. Since x is being multiplied by 2 and then you're subtracting 1, we're going to undo the subtraction before we undo that multiplication because we go in the opposite order. So we're going to add 1 to both sides first. Adding 1 undoes subtracting 1. So we're going to do exactly this. And let's write it in up here. So we're going to add 1 to both sides, giving us 18 on the left and 2x on the right. And then we're going to undo the multiplication by 2 by dividing by 2. And we're going to divide both sides by 2, giving us 9 equals x. So 9 equals x, or x equals 9, is equivalent to the original equation, and this one tells us what the solution is. So x equals 9 is the solution to this equation. Let's now get some practice with additional equations. We want to solve each equation for its variable. Well, you got to first be able to identify what's happening to the variable. So we've got the variable x here in this equation. X is first being multiplied by -2, and then you're adding 11 to that expression. Well, we undo the adding 11 first because that's lower tiered in the order of operations. Remember, we're going in the opposite order. So how do we undo adding 11? Well, we would want to subtract 11 from both sides. Again, you have to do it to both sides to maintain the balance. Balance is the key when solving equations. When you subtract 11 from both sides, we're left with just -2x on the left-hand side, and 37 minus 11 is 26 on the right-hand side. Now we will undo the multiplication by -2. To undo multiplying by -2, we would divide both sides by -2. On the left, we get just x, and on the right-hand side, we end up with -13. X equals -13 is equivalent to the original equation, so the solution to this equation is x equals -13. Let's take a look at this one. In this case, x is being divided by 3, and then you're subtracting 1 from that quotient. We've got to undo that subtracting 1 first. So to undo subtracting 1, you would want to add 1 to both sides. 24 plus 1 would give you 25 on the left, and then x over 3 minus 1 plus 1 would give you back just the x over 3. Now x is being divided by 3. The way to undo division by 3 is to multiply both sides by 3. Over here, you end up with just the x on the right-hand side, and 3 times 25 gives us 75 on the left-hand side. 75 equals x is equivalent to the initial equation. X equals 75 is the solution to the initial equation. We now have 11 equals 7 minus p. With this particular equation, you need to be careful. Remember, you cannot read this as p minus 7. Subtraction is not commutative. This is 7 minus p. So it's 7, and then we're taking off p. So we first need to undo that 7. We don't want to have 7. How would you get rid of $7, for example? You would subtract 7. So we're going to subtract 7 from both sides. 11 minus 7 gives me 4 on the left, but now I've got to be careful. On the right-hand side, 7 minus 7 would give you 0, but then 0 minus p would not be p, it would be the opposite of p. So we have 4 equals the opposite of p, not 4 equals p. Now, how do we isolate p from here? This is the opposite of p, not p itself. Now recall, opposite of p really means -1 times p. You get the opposite of something by multiplying it by -1. So really, p is being multiplied by -1, and you can write it in there if you want. So now you see p is being multiplied by -1. The way to undo multiplication by -1 is to divide both sides by -1. On the left, 4 divided by -1 is -4, and on the right, we get just p. So p equals -4 is the solution to the initial equation. Now that we've solved several multi-step linear equations, let's return to the initial application we looked at that motivated our reason for studying linear equations, and it had to do with Radical Gym. So recall, Radical Gym charges a one-time initiation fee of $120, then $6 per workout. Let W represent the number of workouts and let T be the total amount of money spent. And we've already discussed that the total amount of money spent, T, is a function of the number of workouts, W. So we're using function notation here. We decided to let the relationship between T and W be named F. So we've got F of W equals 120 plus 6W. Our question was, if Keisha has spent $600 in total at Radical Gym, how many times has she worked out? That $600 is not a value of W. We're not going to plug in 600 for W. 600 is the value of T, or 600 is the value of F of W. So we're going to put 600 in place of that entire F of W. So we've got 600 equals 120 plus 6W. This is what we started our linear equation solving screencast with, but we didn't actually solve this equation. Now we will, since we've discussed solving multi-step equations. So W is being multiplied by 6, and then you're adding 120 to it. So we need to undo the addition of 120 first by subtracting 120 from both sides. When you subtract 120 from 600, you've got 480. And when you subtract 120 from 120 plus 6W, you end up with just the 6W. Now to undo the multiplication by 6, we want to divide both sides by 6. And we get 80 equals W. This means that if Keisha has spent $600 in total, she has worked out a total of 80 times.